everyone. I think I'm going to start now. Grab your seats. Hello, I'm JOÃO PROENÇA. This is my talk, a little less testing, a little more quality. I am an expert quality engineer, and I come from Portugal. I was born and raised in Lisbon, and I still live there. I've lived there my whole life. I am an expert quality engineer, as I said, but over the past 17 years, I've done a lot of different stuff in tech. I've been a developer. I've been in customer support. I worked in ops. At one point, I went into marketing, and 6 months later, I came back because I came to my senses. But for the past 7 years, I have been happily doing this role of a quality engineer, which I love to do. And today I'm kind of here to talk to you a little bit about that. When you look at the title of my talk, a little less texting, a little more quality, you're wondering what exactly do I mean with this. And there's a heavy disclaimer I want to make here, which is this is in no ways a talk about how we shouldn't be doing testing or anything like that. Being a quality engineer and with a background in quality assurance or testing, I fairly believe that testing is a very important thing within software engineering, but I also believe that quality is over-encompassing and it implies a lot of different things, and testing is just one of the ways we have to influence it. So that's the disclaimer. So here's a quick agenda for what I want to cover today. I'm going to start by telling you a small story about testing. Then we'll proceed to talking about quality risk and different ways of mitigating quality risk, or managing quality risk, let's say. And in the end, I'll go a little bit how you can think about how the multiple dimensions that quality within software has. Okay? So, starting with the story. Once upon a time, so as I told you, I come from Lisbon, Portugal. But I have a number of friends that grew up with me, but at some point when they started working, they all moved into the Netherlands. They moved into the northwestern part of the Netherlands because they went there to work for ESA, the European Space Agency. There's a big research and development center from ESA in a place called Noordwijk, which is in the northwestern part of the Netherlands, near the beach. And one day I went there to visit them, and I stayed with them for a few days. And they ended up inviting me to visit the facilities, the S-Tech facilities. Now, when I say invited, they totally infiltrated me in. I wasn't supposed to be there. It was all clandestine. So please don't say it's just going to be our little secret. Basically, a group of engineers walking into the center. I was in the middle and no one noticed. But that was a long time ago. Nevertheless, it was a fascinating experience because they started showing me all of the facilities where they do a bunch of testing, essentially. Not of software per se, but of hardware. Basically, we need to send stuff to space. We need to send satellites, rocket ships, you name it. And we need to test these things really well while they're still here on planet Earth, because if they can't sustain the aggressive context of space up there, then we're not going to fix that in production, if you know what I mean. And so I started going through all of these different rooms, and it was fascinating. First, I went to, I don't remember the name of the room, there's a very fancy name, but it was essentially this big hangar that was about setting up a vacuum conditions and simulating the sun. So essentially, you place a piece of hardware in the middle over there, you turn on this very large light bulb, and then it's like, if you're standing there, you're going to fry to death. But you want to see if the hardware is able to sustain those conditions because they're similar to what they will experience in space. Another room was all about sound, which was fascinating. So essentially, you put satellites in the middle, and then you started pumping up the decibels to see if it would sustain the experience of a rocket ship taking off from the rocket center, because that's the thing that will happen in order for these things to get into space. And then there was one that was really, really interesting, in which it was all about simulating conditions where radio waves do not get reflected back to the equipment. So in that room, there's a lot of cones in the walls. They're filled with carbon powder that absorb all of the radio waves, and that simulates what will happen in space when you have a satellite that's emitting waves outwards but doesn't receive them back, to see how the electronics of the equipment would handle those sorts of conditions. Now, as you see, us within Europe, we are putting billions of euros into building these facilities in order to test things thoroughly so that we can send them to space. And this was at a time when I was at the beginning of my career, and I was a quality assurance engineer. My work was to test software, essentially, with a heavy focus on test automation. And that made me wonder a lot about what I was doing, because I started, in a humble way, I was going back to my country and I was thinking, well, I don't test the software to this degree. Maybe I'm not doing my job correctly. Because I don't go to these extremes in order to test the software, and sometimes we have incidents in production. However, it also made me think about, well, what I just saw there isn't exactly what we go through when we're talking about software. And if you go back a little bit in time into the, let's say, software history, or let's say video game history, back in the day, sending video games to production was kind of like, was closer to sending rocket ships to the moon, if you know what I mean. In the sense of, let's imagine the first Super Mario Brothers. Once the software was ready to go and it was fully tested, and they made sure that it was tested, they would, create a golden master cartridge that went into the factory. They would produce thousands or millions of those cartridges. And if one bug had escaped into production, let's say, that was the end of the game as we know it, because you would have to recall cartridges, you would have to rebuild all of the cartridges, and that wasn't sustainable. So back then, it was let's say, a deal-breaking bug would totally kill your product. And so even though games were a bit simpler than they are today, they took testing really, really seriously, because the risk of something bad happening once the product was out there was really high. This, in fact, actually happened. There's a very known case of E.T. the Extraterrestrial, which was a game that came out in 1982 for one of the Atari consoles, and development was rushed because the movie came also out in 82. There was a lot of pressure for the game to have a release timeline that was close to the movie coming out. A lot of corners were taken, bad design decisions, and a lot of cutting corners in terms of testing that didn't happen. A lot of bugs. The game was basically unplayable and a mess of a game. Even though there had been a lot of investment into it, it actually caused the first crash in the video game market, which then set up the stage a few years later for the resurgence of Nintendo and Sega in a new era for video games. Actually, these games, they actually ended up in a landfill somewhere in the desert in the US. For a time, people thought this was a myth, but they have dig up that piece of land, and they have found the video games in there. Okay, but if we fast forward to this modern age, the age that we live right now, things are completely different, as you probably can imagine. Nowadays, the way in which you can patch software after it's released gives you a whole bunch of different options and different ways at looking at the risk of what you're releasing into production. We're not sending video games into space anymore. We can actually go there and then patch them. And if there are video games aficionados here, they will probably know that you can buy a video game on launch day, and there's already an update for it once you place the disk into the console or something like that. One very good example of that, on how things can be handled in a different way, came a few years ago with the game Cyberpunk 2077. So this was a game, a really awaited game that when it came out in 2020, it was a big bomb because essentially it was a very complex game. Really, there were a lot of expectations around it. It was ambitious, but on the quality department, things weren't that good, and so there were a lot of bugs, and a lot of people deemed it was unplayable. Reviews were horrible, and people just said, well, I guess that's it for Cyberpunk 2077. But the company that was CD Projekt Red, the company that was behind the game, they pressed on and they thought we can still salvage this. And they started releasing patches after patches, not giving up on the game, to the point where a few years later, the first expansion came for the game, Phantom Liberty, and it had rave reviews. To the point where reviewers were looking at this expansion, which was kind of like a sub-game within the game, and they were saying, well, this is a completely different game than the one that I reviewed 3 or 4 years ago. And some of them even went as far as, let's review Cyberpunk 2077, the original one, now with the current set of features, with the bugs all solved, and it ended up having good reviews. Now, of course, that this sets a new stage for, and we all know this, the way we can deal with bugs that end up in production and whatnot. I'm not here advocating for us not testing games, which we were doing to a big extent back in the 80s because of the added risk. However, I think that back then, games were also simpler, so they were easier to approach from a testing perspective, whereas today, there's going to be things with so much complexity put into these games, there's going to be things that you're not going to find out just by testing alone. And this is, as I was saying, this is a controversial topic. This is a tweet from last week, and recently one of the things that has been in high discussion is how within AI, with all of these different devices that come and that are supposed to be our physical AI companions, they have been having a lot of bad reviews, and mostly because they reach the market in a state where they're not fully functional, or they don't have all of the features, they're half-baked, and they have a lot of bugs, a lot of quality problems. And so there's a lot of discussion right now about, is this a fair, let's say, is this fair play within the industry or not? But if you think about all of these things, sending rocket ships to space or releasing software in 2024, we need to think about all of these things, in my mind, as risk. It's all about the risk of what you send into production. And for me, there are many ways in which you can analyze quality risk when developing software, when within a software engineering organization. I like to think that the ways we have to manage risk, quality risk, are confined to 4 different areas. You can prevent the risk, accept the risk, transfer the risk, or observe and react to the risk. Okay? Now, starting with the first one, when we talk about prevention, that's where most of the testing ends up happening, at least in my mind. If you think about a quality risk, and the quality risk is like something bad that can happen with your software, and you can model it through what is the impact of that event happening in production versus what is the probability of that event. When you do testing, you're essentially trying to lower the probability. You can imagine certain things that may happen. You can explore for things that may happen before releasing it into production. If you make sure that they won't happen, then you're just lowering the probability of something happening in production. But sometimes there are situations where there isn't, per se, an easy way of testing something out. The other 3 are also important in the sense of, like, sometimes there are risks that you can just accept. But if you're not thinking about risk before you do any testing or before you start putting in measures for things that may happen in the future, if you're not adequately analyzing the risk in terms of impact and probability, then you don't get into a situation where it's like, well, actually, we've talked with a bunch of people, we've gathered a bunch of data, looking at this, it's an acceptable risk. It's something that we can live with, and we're not going to do anything about it because we prefer to concentrate our efforts on higher risks or more critical risks. And there's many ways for analyzing risk within software engineering. I'm really fond of one that's called risk storming, which is something that I can share with you later on, links to it. and you can find a lot about it if you just Google for it. There's also the concept of transferring risk, which in software I don't see that often. Transferring is basically what you get when you buy insurance for something. So when you have a car, you have to buy insurance for it, and you're basically just covering yourself in terms of the risk of having an accident. The financial penalty that you have, or that you're just transferring that into the insurance company. But from a puristic way of looking at risk, it is a concept that exists. It's transferring risk to another entity. But then, one thing that I find very interesting, especially in the work I do on a day-to-day basis, is about the risks that we can observe and react to in a better way, rather than trying to prevent, rather than trying to test for. And for observation and reaction here, I'm talking about getting really good at understanding if those risks are happening in production, being able to identify that the risks are materializing in a fast way, and also having whatever's necessary in place to react to them quickly. Because if a service goes down, but it takes you a day, or the client calling you telling that your product is not working, that is a long time the service is down. However, if you already have those measures in place, a service goes down, this is a simple example, you identify it immediately, maybe you even have automated processes in place to try to bring it back up, then all of a sudden, if you think about the probability versus impact of the thing, you're basically lowering the impact of the risk. If the thing actually happens in production, it's not going to be a big deal because you are ready to react to it. And I've been in these situations where I've faced these systems that I call them too hard to test, or at least too hard to test in all of the ways we wished we could test them. One example I have of that was that I worked for a very long time in a company that they used to own a web and mobile development platform. So it was a low-code platform, so essentially we had our own programming language, our own compiler, our own IDE, monitoring tools for version control, you name it. And our space, our domain, was essentially people building applications using our language, which is a very complex space, as you can imagine. It is filled with unknown unknowns, in the sense of I can build applications, I can think of a number of different ways people will set up web screens or mobile screens and logic and databases and whatnot, but I will never be able to come up or predict all of the weird things our users will be able to do with it. And so it was basically a situation where it was impossible to test the system to its full extent. And that meant we really had to invest in being better at observing and reacting to problems. And I remember that when I became a quality engineer within that company, I arrived at the team. We were doing this new thing where we were addressing software engineering and quality and testing within software engineering in a whole team approach to testing way. And I arrived at the team, and this was a very, let's say, particular setup where we were dealing with a very big monolith. So the platform I'm talking about, it was essentially made up of a lot of modules. Classic old-style architecture, not service-oriented, and those modules would be, they had this very complex build process that eventually had a final artifact that was just a binary where everything was inside, and then we had clients that were still running them on-prem in old-school servers, but we were also serving the cloud using that kind of like old-school architecture. And the problem with being in this setup is that our release cycles were horrible. I mean, I'm talking about, if I remember correctly, we were releasing new features every 3 months, and patches for bugs were coming out each month. And the problem with this, and people were getting really frustrated quality-wise, is that the more we tested stuff, the more we would go to production, have bugs popping out in production, and then the impact of those bugs was enormous because, hey, the next release cycle is coming in 1 month, so we need to find ways of dealing this for a month, or we have to produce a hotfix with all of the implications that has in a very big monolith within an engineering organization with hundreds of engineers. And of course, there was this very baffling thing within the organization, was that people were living within that, let's say, social context, but they believed that the reason we had so many quality problems was because we weren't doing enough testing. As soon as I arrived to my team, they said, well, I guess that now we have the person that's going to test this to their full extension, and they're going to find all of the bugs, and we can release confidently into production. But then that led, of course, to more like, okay, if you want to test this, all of the things that we could possibly test, 3 months is not going to cut it. You're going to need more, and that's just worse for the situation that we have. So as I became a quality engineer and being already attuned to this whole way of thinking about quality, not just as testing, but more than that, I started thinking, well, the problem is not the testing that we do. I have a lot of experience in testing. I had a lot of experience in testing by then. I'd say we're actually doing very good efforts in terms of testing, but our release cycles is the thing that are killing us. And looking at the monolith, well, what my team owns actually could very easily not live within the monolith. So what I told them is that, well, I'm the quality engineer, but I'm not going to work in testing. I'm going to work in something else, which I'm going to take us off the monolith, meaning the team owned a number of web applications that were consoles for administration purposes and for monitoring. So people just used our consoles to set up users, permissions, for logging, for checking versions and stuff like that. And I thought, well, if this is just a web application that interacts with the underlying platform, that seems kind of the thing that I can, release separately and not be attached to the monolith. And that's just the leftover of the original architecture that you can, easily change. And so I set into my, let's say, my big quest for, okay, I want to start having independent releases. I want, from an architectural perspective, to detach our consoles, the assets that my team owns, from the main monolith, so that we can become independent and release independently, which very naturally will mean releasing more often. And that was a very, very long journey towards my goal. The first thing I had to do was getting team buy-in, because as I said, they were all just saying, no, you should be testing more. Why are you thinking about these things? You're not an architect. You're not the DevOps person. But once it took a bit of convincing, but they bought in. And the next step was getting business buy-in, for the business to understand what was the value of this, that we weren't just doing this for kicks. And this meant me working with the PO and even with product managers on setting an actual business case for the initiative I was trying to create. But they ended up being easy to convince as soon as I demonstrated. If we do this, we predict that we can start, releasing every couple of weeks. And that was magic for their ears, And this, for me, was getting everyone to agree on the value of what we were trying to do. Next came talking to the architects. Basically, okay, we're going to detach this from the main monolith, but of course that has architectural implications, not just from, certain APIs probably will need to be open, as well as how does the lifecycle for those APIs is going to look like, not just for my team, but also to the other teams, because we need to align on that. We don't live in that world, that comfortable world where everything goes in the same package to production. We need to think about stuff like breaking changes and whatnot when you update an API to the next version, or when the consumer ourselves is going to production as well. And this part of aligning with the other teams was very hard to do, because it was probably the place where the added value wasn't as obvious for them. What's in it for them, right? It's like, you're bringing all of this work to my plate, but you're going to get a much better life than I will have. I will still live in a monolith. Still, I could count on the good nature of people, and eventually I had agreement from everyone on the how. How are we going to do this? Okay? And the final stage was agreeing on doing, which meant getting leaders within my organization for allocating effort to actually implement this initiative, and telling teams, not just my team, but also other teams, let's bet on this, because this is probably a good idea, and it will set the stage for other teams to start doing the same thing, and slowly carving away the monolith. as you can see, these are a bunch of different activities I had to do throughout a 1-year time period that have little to do with testing, and they involve a lot of different areas. But I was there being the quality engineer, being the driver for the initiative, because at the end of the day, I thought that the main driver for this was quality rather than everything else. One of the very interesting things that I found throughout that journey was over there in that architectural changes step, when I had to interact with all of the architects. Getting all of the architects within a room to argue about an initiative like this was interesting in its own. They kept fighting each other. It was really, I thought at some point that the initiative was gonna end up being canceled because I just couldn't get these people to agree on the topic at hand. And this was before the pandemic, so I'm actually talking about an actual office room, these folks coming in, and then just at some point people were raising their voices, and I'm like, okay, this is clearly not working. Funny enough, yesterday there was a very interesting talk about conflict that made me think a lot about this small part of my career. But then one thing that ended up, after talking to a bunch of people about the topic of facilitation, how can I facilitate a session that makes this decision-making more successful, I ended up coming with an idea of just changing the medium. If people are getting into a room and talking to each other and arguing, maybe if we set up another medium, they will be able to think things in a different way, and that ended up being really successful. So basically, I just created a big document where I brought in, I kind of like did a curation of all of the different opinions and all of the different data that we needed in order to make these decisions. The arguments and the discussions ended up going into common threads within there, but it was better for them in order to, let's say, to not become so emotional or so invested in specific details, and we ended up being able to arrive to specific decisions. For me, this was really interesting because usually I think, and my career tells me that getting people together to talk face-to-face is usually better, but this was one of the rare occasions where that was exactly what people did not need. But as I was saying, learning how to facilitate these discussions and learning how to set up the right context for a group of very intelligent human beings to come to decisions about software architecture, that was definitely what I didn't expect I would be doing as a quality engineer, but at the same time, it was motivating, and it was clearly the thing I had to do at the time. And to be honest, that initiative ended up being a big success once a specific event happened. So we took 1 year to get the thing done. After 1 year, we released the first independent release of our consoles. 1 month later, we released again. The team got so confident with being independent and doing things alone that they started very quickly releasing every couple of weeks. And after a few months, oh shit, sorry about that. Of course, Slack wants to update. And after a few months, I got this quote from one of the customer support engineers, an L3 engineer that was really an expert in our console, saying, "This component is now in a much healthier state than it was a year ago. Getting its own releases clearly improved quality in multiple ways." Because all of a sudden, the customer support engineers that were feeling the production fun in the field, they started thinking, well, if there's a problem, I know that next week I can probably get a fix into production. And that was clearly a success in our book. Within that, and this taught me this very important lesson, that you can't test yourself out of a broken release cycle. There's no amount of testing that will, make your 3 months or 1 year releases more stable than they are, at least in my perspective. Okay. Over those years, we did a lot of different things where quality engineers, the team started to grow. Quality engineers started working on other things that weren't exactly testing, but were really important for us in terms of handling quality risk. One of them was controlled rollouts. essentially being able to release to production, but segmenting the clients that you are releasing your software to, starting with the internal clients, then the let's say the more risk-prone clients that were eager for new features but were willing to take a little bit of risk in the form of possible bugs, and then only leaving the risk-adverse ones to the ends. Another thing that we were really obsessed about was developer feedback loops. I guess that for people that have seen other talks at this conference, this doesn't come as a new thing. But for us, we had already recognized within our own engineering organization that the longer the feedback loops for our developers in terms of either our test automation, and we had the big test automation suite covering the monolith, or because of client user feedback, or even exploratory testing feedback, the longer that feedback was, the harder it was to fix problems. And this actually ended up verifying something I read at the time. Was a research I found in a book called The Continuous Testing Guide for DevOps Professionals, I believe, where they did this analysis with engineering teams, and they found that, for instance, if you take a bug that goes into production, or not necessarily in production. If you take a developer that makes a code change that introduces a bug to the code base, if they found about that bug on the same day, and it takes them, like, let's imagine 1 hour to fix that bug, in the same conditions, if they only find out about that bug at the end of a 2-week sprint, so 15 days later, usually the time to fix will skyrocket to 8 hours to a full day, just in terms of context switching, the code change now being let's say contextualized by more code changes that happen on the side. All of those things end up adding up to an 8-time surplus of time that it takes to fix something, and that time can even go higher if we're talking about stuff that you only find out about in production 1 month later, or 2 months later, or even a year later, because it's a corner case. So for us, it was very important that our developers found these problems a lot of times from test automation as soon as possible. Oh. Another thing that we did a lot of investment was moving from a feature branch model into trunk-based development, which within a monolith is kind of chaotic, but funny enough, it brings a lot of advantages, even though it would be counterintuitive that usually people prefer to be in a feature branch condition. This ended up reducing the 3-month releases that we had, because it actually proved itself to be faster to be in a trunk-based setup rather than having feature branches with such a big code base. Okay, so I've covered a bunch of things up until now, and we've been talking about ways I've seen in my career where I was able to influence quality without doing any testing, but we're still not seeing exactly the whole picture. Up until now, I believe I've only been talking to you folks about one sub-area of what quality within software means. And in order to understand that, I think that we need to kind of like look at what exactly quality means within software. Usually when I want to explain myself, I find myself using this model. I didn't create the model. Dan Ashby, who is a very known person within the testing space, created it. He also happens to be my boss, but that's another story. And he came up with this model that I find very interesting. So for him, quality consists of 3 vectors. It's usefulness, correctness, and goodness. And you can think about this in terms of software, but also in terms of other things. Let's take, for instance, a bicycle. Okay, what is quality within a bicycle? What is the usefulness of a bicycle? It needs to allow you to fulfill something that you need to go to work every morning, and come back. That's the value or the worth you get from your bicycle. What is the correctness within a bicycle? Does the components of the bicycle actually work as you expect them to? Are the brakes working? Is the chain actually connected to the wheels and makes the wheels turn? That's meeting expectations and your wants and needs. Finally, the goodness is the emotional experience you have while riding the bicycle. Is it comfortable? Does it look good? Does it make you look like a douche? So those kinds of things. And all of these things end up adding up to what quality ends up being in our hearts or in our minds. Up until now, if you pay it, if let's say, at least in my perspective, I believe we've only been talking about correctness. And that's usually when we focus our perspective of quality when we're talking about testers or we're talking about quality engineering. But the other two can totally kill correctness in the sense of like, you're not going to get a high quality product if you only focus on correctness. Here are a few examples that I've seen around me throughout my career. About a year ago, I was talking to a fellow quality engineer of mine at the new company I work right now, and he was working on this product, this new sub-product from the company, and he was telling me, it was basically a coaching session, and he was telling me, you know, João, I have this small thing in my head telling me something's not right because my team is building this new thing. We're building it with amazing UX. We're building it to correctness. We know the requirements. We know what it needs to do, but I have no idea if we're going to get any users. And if the users are willing to use it in any way, I don't know if it's useful. However, I also don't want to step on people's toes, and this is kind of like product management, product ownership. I'm assuming that there are people that have made their homework regarding this, but I'm not entirely sure, and I'm a bit afraid of asking those questions and stepping out of line. And I ended up coaching that person actually to, no, that's exactly what you should do, but there's no correctness in this world or a goodness in this world that will make such a product successful. He ended up, slowly starting asking questions. Some of them were uncomfortable questions, and that project ended up being shelved because of that. It had to come from the quality perspective and testers within the company thinking, yeah, this all seems great, but we don't imagine a lot of people using this. And that's another lesson for me. Is like, testing won't fix a useless product. There's no amount of testing for that, other than maybe, testing it with real users and understanding that if it's something they would use actually. And testing with real users is actually a lot of times connected with goodness, as you probably can imagine. When you go to the goodness, I have another story to tell, which was a few years ago, another company I worked in, we used to have this health insurance plan that was applied at the company. Everyone benefited from that. I had it, my kids had it, my wife had it, you know the drill. But back then, in my country, for some reason, all of these insurance companies were still basically dealing with reimbursements in a paper-based way, which was really frustrating. So anytime I had a reimbursement claim, I had to fill out a form, place it in a letter, and send the letter, to the point where in the reception of our building, there's a big cardboard box where people were just dropping their letters because they just send them in bulk to the insurance company every single day. And one day, I arrived there at the cardboard box, I drop my letter, and there's a colleague of mine that's coming up. He passes by me and is like, hey, João, what are you doing? I'm sending the reimbursement to the insurance company. And he was like, oh, you don't need to do that anymore. There's an app. And I was like, whoa, there's an app? Finally? What it's like? And to this day, I will remember his answer because it made me think a lot. He said, it's awesome. I mean, it actually sucks, but it's awesome, And what he meant was that, yeah, it was awesome in the sense that all of a sudden, yes, you could file reimbursement claims through the app. It was possible, but the experience of doing it was excruciating. It was terrible. It was riddled with bugs. And then you started, memorizing the way you would work around those bugs. But still, the experience of an application that wasn't, which was highly useful, but it wasn't that good in the goodness part, was way better than having to send things in a paper form. Of course, that later on, all of the insurance companies started building their own apps, and it's the most normal thing nowadays. They started building apps with better user experience, and of course that insurance company got into trouble because that success with that app was short-lived, because it was so riddled with problems that it was easy to disrupt by other companies investing a little bit more in user experience. But it shows to you, once again, sometimes you can put a product into production. You deem that it has high quality from the feedback that you get in terms of usefulness and correctness, but the goodness is something that may hurt you in the long run. Okay, this was just to illustrate what I just said. Now, quality. I described a number of different things throughout this talk that I've been involved with in one way or the other that ended up proving that they influence quality for the software products that I was involved in building, and they weren't testing per se. You will find probably, though, that some people argue, just for you to imagine, that a lot of these things are actually testing as well. And I can't believe I haven't said the word observability yet, because I'm a big champion for observability. But it's just about testing at different stages of the development, the DevOps lifecycle. Okay, this is yet another model from Dan Ashby, where he looks at it in that perspective, that a modern quality engineer is supposed to be testing not just on, let's say, the phases we expect him to be testing, namely, when we're coding or merging or building. It's actually testing at different stages. When we're deploying or when we are operating, we're talking about understanding how good are we at looking our software in production. How many unknown unknowns can we answer there? How many questions we can answer? Observability. It's also about planning stages where you look at the architecture of things, you question the architecture of things, because those are the things that may be hurting you from a quality perspective. It's looking at release cycles, branching strategies, all of these different things, and it's doing testing per se at those stages. And my main message here is that you probably have heard the term quality engineering more and more in recent years. And what I want you to take home with you is that the term isn't just a, let's say, naming what we were already doing in the past. We used to have testers, then quality assurance engineers. It's not a new name for it. It's actually a new paradigm where we are looking at the way we release high quality products, all of the factors that go into making that, and having professionals that are focused on anything that needs to be done, or any sort of influence you have to have in terms of your engineering context in order to be able to release things with such a high level of quality. Thank you. Don't forget to rate my session. I was going to delete the don't forget to rate my session, but then I did find there's a way to rate the sessions in the mobile portal, so please do that, and any feedback is welcome, as well as any question that anyone may have, because we still have a few minutes. Or if you prefer in private, I'll also be around until the end of the conference.